everyone, and welcome to the first session after the great keynote from Massimo, which already helped us a lot so that we don't have to explain everything from scratch. So, yeah, welcome to the presentation about what we learned when we started to build an AI agent or a Slack bot, and we call it From MacBook to Bedrock. My name is Linda. I'm here with Philipp.
Hello.
And yeah, let's jump into the topic. So first, let me quickly introduce myself. So already mentioned, my name is Linda Mohamed. I am a self-employed cloud consultant and also an AWS hero. Some facts about me. Although I was working as a Java software developer, I call myself a prototype developer. And I would say I learn fast by asking a lot of people and by over-engineering topics a lot. And also, I'm very, very passionate about efficient processes. Other than that, I do a lot of voluntary things. I'm in a lot of different support associations. I'm also the chairwoman of the Förderverein of the AWS Community Day Italy. And I am, as already mentioned, coming from the Java software development, and for around about 5 to 6 years or 7 years already, I'm focusing on cloud technologies and AI.
So, hello again, my name is Philipp. I work as a so-called managed OpenShift black belt at Red Hat. I would also call myself a prototype developer. That's why my job is kind of perfect, because I only do POCs with our customers, and that's kind of as far as I can go mentally. I can also learn fast, but I prefer to learn alone. As you can see, there might have been some friction while we were working on this project, but we came along. And I am personally passionate about open source. As you can also see, I don't do as much things at Linda, so I mostly work, and we're both the user group leaders of the AWS user group in Vienna, together with Dimitro, who is also here, and 2 others. Yeah, I'm a Kubernetes and cloud and AI enthusiast. I would also call myself a software developer. Some of you might disagree, especially Linda, since my background is more in PHP, and that's not like so common anymore. And of course, I specialize in Kubernetes, and by now a lot in AI. Basically, mostly because of this project. So let's kick it off. First of all, I want to say we did not do this because it's easy, but because we really thought it might be easy. It turned out to completely not be easy, and that's why we have a lot of content today, because there were so many things we faced while we tried to build our agentic bot. But bear with us, I hope we can explain all of the components. So the other thing that we've seen is when we submitted for the call for papers for these community days, the AI landscape was like completely different. It was like there was no DeepSeek reasoning model. There was no Bedrock multi-agents. There was no Claude 3.7. There was no Gemma 3. There were not the new Mistral models. And it was like some hours ago when it was announced that Bedrock agents now support model context protocol, which also would revalidate our decisions, but we decided on a stack which integrates a lot of these newer technologies which came up like last week or the week before, but we can't cover everything, and I think probably tomorrow we would have built it different.
Perfect. Thank you so much for the introduction. And let's start with our use case, because today we're going to talk about or share with you how we organize an AWS meetup and how we actually supported this organization with a chatbot. So the first thing, when you think about starting something new, for example, starting a new user group or starting to learn a new technology, you're kind of just like studying a lot, learning a lot, trying to get like new experiences, and you end up learning like a lot of different things. So this could be that you're starting out with AWS because you want to build a user group in your region or in your city, and additionally to that, you're also yourself starting with AWS fundamentals. Then you start learning about event planning and logistics. You start learning about how to build a community and how to do proper networking, and also public speaking and communication. And last but not least, you have to learn how to continuously learn and how to experiment in order to get your meetup or your user group, for example, to the next level. So while a lot of things are there that you can just learn at home, like watch videos, try different things, so you can acquire AWS fundamentals by, I don't know, watching videos and trying things. Also, the event planning. There's a lot of things that you can read about it, but then there's also a lot of things that you have to experience. So you really have to do a meetup to get to know your community, to get to know what could be the challenges that you're facing in your region, for example, and also in order to get to know more people and to reach out to the community. And in the end, of course, this is just a fictional story, but what being a solo user group leader feels like is kind of every time when you try to automate something or build something, it kind of breaks all the time because you don't have enough time like to focus on everything at the same time. So when I tried to rebuild like the whole story, how I started learning those new technologies and also starting to be a user group leader, I wasn't burned out, but my sim was burned out. When I tried to do all of the things at the same time, my sim told me, oh, he's burned out or she's burned out, and then I was like getting this message of fake it till you make it. It was like asking me, oh, do you want to go solo or do you want to ask for help? And I was like, okay, actually, I really asked for help because back then when I was doing the user group alone, I reached out to Philipp again, and Philipp joined the user group leader team again after he stopped doing the meetups because of COVID. So we already mentioned it, but we ended up now having almost 2,000 members of our user group, and we have in total 5 organizers. And I think we're doing a great job in having like a great community. But then we found out, okay, so we have a lot of knowledge, we have a lot of experience, but how can we like give this experience and knowledge also to others so that it actually scales, because you cannot answer questions all the time, because then we would have like the same amount of effort that we had doing things alone. So we decided to build Otto. Otto is our Slack bot and our user group assistant. So Otto now helps us to take over tasks. He has like an army of agents that are doing different things. It's like the meetup manager, the agenda producer, we have the speaker finder, and we have the GitHub planner, because we are organizing all of our meetups in GitHub, like in a GitHub project. And last but not least, Otto can finally take over tasks that we used to do ourselves. And now let's have a look at how Otto is actually working. And we're jumping in the first demo of today. And this is live, so bear with us. We already heard, like, can you trust those agents? We will see if we can trust those agents. But so Philipp will now ask a question to Otto. Probably we will experience like a little bit of a cold start, so it takes some time until everything is up and running. I hope you can see it. And actually, we're asking now, hi Otto, we are currently planning our meetup for May 2025. Do we already have any speakers available? And I think this is interesting because we just tried it with April.
I wanted to try something new and see if it breaks.
It's the perfect timing to try it live at the demo. So, okay, so it takes a little bit, what's happening in the background. So we have an app runner environment running where Crew AI, and we will explain all of that in the whole talk, where our agents are running in the back. We're also using a custom model because we found out that we're doing a lot of things differently as other user groups are probably doing it. For example, generating the agenda. We always have like at least 20 minutes break in between both of the talks. Usually user groups don't do that all the time, so that's why we always have a little bit more information.
And now we can see a perfect example of some hallucinations. So it correctly found out that Tom and Philipp are our available speakers. But Otto is really trying to have a diverse lineup of speakers, so he always, kind of, what's the name? He adds a random female speakers that are not like really there. So we should not probably try it with a new question.
Try it again. Try it once with April. Probably
but
it works.
we have it in the history.
Yeah, we have it in the history. So yesterday we were
yesterday.
actually asking if Otto is still alive because just like checking in if he's still here. So he told us he's very much alive, and he also generated the agenda for the next meetup, which is correct. It's kind of a coincidence that every time when we're on the stage, Otto starts to hallucinate a little bit. It's like probably he has like, I don't know, stage fright, I don't know. Yeah, so, but what's happening in the back, we are going to go into detail now. So, Philipp, do you want to explain us how the agents are working together?
Yeah, so that's like a really simplified visualization of what's happening in the background. So if you've seen, our entry point is Slack, and then there is like, we're using CrewAI as our agentic framework, and we are currently using 3 different agents. A Q&A agent, which is prompted to respond to the questions. A user group specialist, which is using our custom trained model, which we're going to explain in more detail later. And the speaker finder agent, who has a tool connected to it. He's able to get data from our Sessionize. We're using Sessionize to collect submissions for possible speakers for our user group. And basically, when the question comes into this multi-agent process, the agents kind of talk to each other and try to figure out how to respond to the question. And they kind of hand over a lot of times, that's why it takes so long sometimes, and all of them give input on the request, and when they are confident that they have the answer all together, so like Massimo mentioned before, they're reasoning together, then they reply and respond back in the Slack thread. So how did we get there? How did we get from our data to our Slack bot? So we are using like a lot of tools. The most important is probably InstructLab, where we will get in a little bit more detail right now. So what is InstructLab? Do you want to explain that?
Yes. So InstructLab is actually a really, really nice way to fine-tune a model without actually fine-tuning the whole model, but just adding like fine-tuned weights. So actually it's a model-agnostic open-source AI project that facilitates contributions to large language models. So it's based on pull requests, so that you have like a repository where you store all of your knowledge, and as soon as you add more knowledge, like we automated the whole pipeline behind our taxonomy repository, that it always trains the new adapters additionally to the base model. So actually, like this lab method, as already mentioned, is driven by this taxonomy, which are largely created manually and with care. So actually, that's really, really important that this taxonomy, it's like the base of everything that's happening later. So if you don't have good quality data at the beginning, you won't have good quality at the end, because it always starts with having like really, really qualitative data. So, what is actually happening?
That's also a kind of the simplified process, how this even works. So the first step is to kind of document your knowledge. So in our case, since we're using InstructLab, we created a GitHub repository with markdown files where we documented how does AWS user group work, what is it, how does an agenda look like, what's the target audience, and things like that. Then the next part is InstructLab specific. You have to create, and we will see this later, a YAML file with example questions and answers. So this is basically the foundation. And then the next step is synthetic data generation. So InstructLab basically takes these files with the example questions and answers, and it generates synthetic data, so it uses the knowledge of LLM to create additional questions and answers, which are similar and also cover the underlying document, which is the markdown file. Afterwards, we can take these JSON-L files, which are dropping out of that, train the model, and use this for inference. And since it's shown as a full circle, so the next step would be to kind of figure out, okay, what's still missing in the model, what knowledge is still, there's a gap. So you could start again, document the additional knowledge, and go through the whole process again.
Yeah, and one additional thing to mention here, so everybody who's like a little bit into this AI and machine learning probably already knows about data augmentation. So this pipeline, the synthetic data generation, is kind of a data augmentation. So we just take the data that we already have and we augment it and add more data on top of that. And the process that we're actually aiming for is kind of an active learning process, so that we actually also get back like the knowledge or like the feedback that we get like from users while using this model. This is what InstructLab also offers and what works with InstructLab.
All right. So the first step when we were going into this project was to actually choose our LLM. And just overview, there are kind of three types of LLMs. They're like completely open source, open weights, and proprietary. What is an open source LLM? It's quite important because it's often confused with open weights. Open source LLM is basically an LLM where the data is open source. You know what's inside. The whole process, how to train this model, is open source, and the resulting model itself is open source. So basically, yeah, you can reuse it like any other open source project. You can build it yourself. In the middle is like the open weights. That's basically the most popular and often confused with open source. Like for example, Llama and Mistral and DeepSeek. And I think DeepSeek is especially a good example because what a lot of people figure out is when DeepSeek came out that it does not have so much knowledge about specific parts of Chinese history. So if the data would be open source, it would be obvious that there is some bias trained into the model, but because the data is not open source, it's kind of a black box. And probably someday someone figures out that DeepSeek prefers cats beyond dogs or something like that, because it was just trained into it and nobody knows. And the third category is proprietary models, models which you can just use. You can't even fine-tune them, you can not run them on your own infrastructure, something like that. So it's just as a service. So for example, Claude or GPT or Nova. So we decided on using 4 models. As a teacher model for the synthetic data generation, we decided to use Mistral Small 24B because that's like the most capable model we could use on my own hardware. Because we forgot to mention it before, our biggest goal was to do it cheap because we're a user group, we don't have money. So we wanted to still do some fancy things, but we didn't want to invest like a lot of things. So we had to use MacBooks and gaming computers and things like that for our data training process. And Mistral was like the largest model running on my GPU. As a base model that we fine-tuned, we decided to use Llama 3.1 with 3 billion parameters. Again, because it's quite small and it was possible to train it on consumer hardware. And for our agents, we are using proprietary models in some of them, and we decided to use Amazon Nova Pro because it's like really cheap, and Claude Sonnet 3.7 because it's amazing. Yeah, do you want to tell us about knowledge?
So, as I already mentioned, this is a really crucial step, and this is very, very important how you actually document your knowledge. So, we of course tried in the beginning to just generate the knowledge based on like some information that we had, like, oh, those are our meetup pages, please generate the knowledge, the documents that we need with like the like information from InstructLab. But it turned out not to be good. So what we actually did, we really sat down and wrote the knowledge ourselves, because you don't need like a lot of data in order to start, but you need like super good data so that you actually can do things. So we started with like just general information on how to organize an AWS meetup in Vienna, which is very important to always be super specific. If you just explain like how to organize an AWS meetup, it will probably not be that good because you have to be like super specific, because probably a meetup in Sweden is different than a meetup in Vienna, for example, or also a meetup here in Milano is also different than a meetup in Austria or in Germany. So that's why we started to like create all of the data really in the way so that it fits to us. So first of all, we have like those Q&A files. It's like we have our markdown files and Q&A files. You always need both in order to, for InstructLab to generate all the data that you need afterwards. So here you can see like the list of files or like folders that we created. If you think this is a lot, no, this is like the third or fourth iteration of getting rid of data, because I was super hyper-focused on one weekend and I generated or like wrote so much data that we couldn't even use it. And we ended up having our pipeline running for several days, you will see it, and we couldn't use the data. So please focus on being like super specific and quality over quantity. So what you can see here is like the different contexts and Q&A pairs. So you need at least 5 different context blocks, in addition to 3 different Q&A pairs.
We have more specific slides for that.
Oh, sorry. Thank you so much. So what you can see here is like the different knowledge, how we build it up. So we tried to first give like a little bit of more information about the general knowledge about AWS community, about the purpose, about event organization, which includes like different information about how to organize a meetup, a community day, a summit stage, or whatsoever. And then we have like the specific example of, for example, here, of the women's user group in Vienna, because we have like different user groups in Vienna. And here you can see one of the examples where you can actually see the context and the Q&A pairs. And now the information, like we need 5 context blocks and 3 Q&A pairs so that the synthetic data generation pipeline is working. And also, probably, if there's anybody who didn't work with YAML yet, actually I didn't know that because I was never working with YAML. You always have to add one line at the end of each file, so otherwise it breaks. So Philipp, thank you so much for telling me that. Now I know how to work with YAML.
Yeah, it's like a major issue. There's like a highly specific YAML linter in InstructLab, so you really have to write great YAML. So the next step, as mentioned before, is the synthetic data generation. So basically, what happens is that InstructLab takes the taxonomy, like a markdown file and a YAML file, and then it uses the teacher model, as mentioned before. We are using Mistral Small to scale these Q&A pairs up by 30 times. So we have 30 times the questions and answers generated by Mistral out of our knowledge and Q&A YAMLs. The result are kind of 2 JSON-L files, one for training and one for testing, and we will use them in our next step to actually train the model. Just to show you how this works, so this is the InstructLab is a command line tool, mainly. So this is the command to generate the synthetic data. So as you can see, it's like really easy. You just have to declare that you want to use the full pipeline. There's also a simplified pipeline, but this does not really work. So we're using the full pipeline and tell which model to use as a teacher model, and then it just starts to generate the data. As Linda mentioned before, in our last attempt, we had like 34 knowledge entities in our GitHub repository. We actually ran this on my OpenShift at home, of course, and in a pipeline, and it took us like 64 hours to just generate the synthetic data. And in the end, we had like 2 gigabytes of training files, and we were like, okay, no. That's not like the approach we should choose. So afterwards, we really simplified, and I think in the end, we had like 100 lines of JSON data to fine-tune our
120.
Model. 120. But not, I think in this case, the result was like 300,000 lines of training data, yeah.
So it would have actually not worked anymore to train that on a MacBook. So we saw that we were like really over-engineering this topic and saw like where we have to focus on, which was also a learning experience.
Definitely. And in the end, it even failed to upload it to Hugging Face. Yeah, so the next step is to actually train the model, and we are using LoRa to train the model. Do you want to explain what LoRa is?
Yes. So is there anybody who already tried to fine-tune a model or train your own model? Please raise your hand. Yeah, okay, some hands, okay. So actually I also tried that in the beginning when there was like this LLM stuff coming up, and then I immediately stopped trying that because it was super hard to actually have the right instance in order to train something like that. So what is LoRa compared to doing like the training from scratch? LoRa is a kind of low rank adaptation technique, and it's a way to adapt a large machine learning model for specific use cases without retraining the entire model. So what does this mean? It actually means that if we take a look at Otto, Otto is actually learning the new knowledge by reading the files that we prepared for Otto. It's like he's reading at the moment about the AWS Community Vienna and how we do our meetups. So this means we are using a base model for the general knowledge, which was the Llama 3.13b. And then we actually just add the domain knowledge as a LoRa adapter. So you can think about that as having like the safe tensor files and having like the weights, and you're just like changing like some of the lines in the safe tensor file, which are actually like the weights for LoRa. This is the only thing that you're changing, and then you're just adding knowledge on top, which means it has to be super specific, because otherwise it's kind of running into the general knowledge. And also thinking about how to choose your LLM, you cannot use like a really, really big model and add a little bit of data, because then you won't realize or recognize your data. So you have to make sure that it's kind of a balance of the amount of data that you have and the size of the base model that you're using.
And again, why did we choose this and not like completely retrain the model? Because it's much more efficient.
Yep.
You need much less VRAM on your GPU, and it's much faster. So this kind of really worked again on the hardware like we had at home. So again, this is like the snippet from the InstructLab CLI. So again, you have like the pipeline that you declare, in this case accelerated, because I have an NVIDIA GPU, I can use CUDA. You have the data path, that's like the training data set that we've generated before. So that's the result of the synthetic data generation run. The model path, that's like the model you want to fine tune. And then these are the LoRa parameters, which I can't really explain, but it's basically completely possible to do this without any knowledge. It immediately worked. Yeah, and again, we tried to do a pipeline. So this is again the Tecton pipeline we've been using, which is triggered by the GitHub commits, and in the end should output a completely trained model. I just had a failed attempt ready, but there were some attempts which actually worked. Your favorite topic?
Yes. So actually, Philipp really loves to work with his CLI, and also doing like all of the pipeline stuff with OpenShift. I'm not so much into just using the CLI and training things with a pipeline. So there's also a way from InstructLab to use a notebook. So if you're like more to using Jupyter notebooks and more of this like prototype engineer, as I call myself, with not having like a full pipeline running all the time when I try to change something, you can also experiment within the notebook that is also provided by InstructLab, where you can also do everything that Philipp also did in the pipeline. You can do in a notebook that you also can get from InstructLab. And actually, we always tried to use like the different ways in order to get experience for both ways. So if you have any questions for either the ways, please reach out, because I don't think that we can go into detail more here. But just to mention, there's different options on how to do things.
Yeah. And as Linda mentioned, all of these things are open source projects, yes. So you can find all of these in GitHub. So then the next component we're using, Amazon Bedrock.
So sorry, if you think about Amazon Bedrock, and another question, who was already using Amazon Bedrock here? Okay, a lot of people. So we don't have to explain it that detail, but actually what we think about Amazon Bedrock, it's kind of our workstation to build different things, because there you have like a lot of different models that you can choose from Anthropic, Amazon, DeepSeek, Meta, Mistral, and a lot of other more models and foundation models. So what we actually used, we already mentioned it, the different models from Anthropic, which is Claude 3.7, how do you say it?
I think Sonnet, but I'm
Sonnet.
unsure.
And we used Nova Pro because it's super cost efficient for our use case. It's really amazing. And always think about if you always need like a super huge model, or if you can use like smaller models in order to reduce your costs a little bit, especially if you're using multi-agents. Then we used Mistral Small as our trainer model, and Llama from Meta, the 3.1 freebie, for our custom model.
Yeah, so the next component is basically CrewAI. CrewAI is like a Python framework to build multi-agent systems, which is agnostic, again, about the LLM and the cloud platform or environment that you're using. So to explain a little bit, CrewAI has like a lot of things, but basically there are like three entities. There's like the crew, which contains the agents, and the agents try to fulfill tasks. So a crew is basically a team of agents. Agent is a LLM plus its tools it can use, and the task is like the assignment that the agents try to achieve. So basically like the goal, as Massimo mentioned before. And again, visualization of our CrewAI setup. So as mentioned before, we have like three agents. All of them have different LLMs. So for example, the Q&A agent uses Claude because with Claude, the chances are quite high that it can immediately respond because Claude just knows a lot of things that you can ask it. Then we have the user group specialist, which is the trained model, which came out of this InstructLab training process. We're using the custom model import for that. And we have the speaker finder with the Sessionize tool, where we are using Amazon Nova Pro. So as Linda mentioned before, it's like really important to decide on the right LLM for the use case. Because what we've seen in the runs of CrewAI is that, for example, Amazon Nova Pro is not really perfect, especially tool calling. It struggles a lot with it. But it completely doesn't matter because it just tries again and tries again. And it's so cheap that you can really try again often, and it's still cheaper than a single inference with Claude. And especially with a multi-agent system, so they will just tell each other, yeah, but I think you did that wrong, and it just tries again. And it tries harder, and then it even works with lower skilled models. And as you can see in the bottom left, we are also having a Chroma vector database, which stores the memory of the agents. So they store all like the results within the agent run in a short-term memory, so they can reference on that. And they are also collecting long-term memory, which came out as a surprise because we asked Otto something which he should not know, but he remembered from a former conversation, which is also like really nice in the end, actually. Oh, we're already done.
Yeah, but we're already running out of time.
Okay.
So then let's have a look at the final architecture, which is super complex, as you can see. So we have the user interacting with Slack. Then we have, as we already mentioned, AppRunner in the back using ECR. And AppRunner is actually just calling the different Bedrock agents that we're using within AppRunner. CrewAI is running, and it's like reaching out to the different Bedrock models, either the foundation models and also our custom model that we trained and, as Philipp mentioned, imported with the custom model import. And our custom model is served in an S3 bucket. So actually, that's it.
Yeah. So basically just AppRunner, we're running a container image with the CrewAI application on it. And yeah, that's like really cost efficient because also AppRunner just goes to sleep when you don't use it. And Bedrock, the custom model import is also just spinning up for 5 minutes at least. And then if there are no more requests, it also goes to sleep again, and you just pay for these 5 minutes. And within these 5 minutes, you can infer as long as you want, and you only pay for these 5-minute blocks. So
every 5 minutes that start.
Yeah. So basically, what all of these costs are is about 30 euros a month. And if you compare it, for example, if you'd use model fine-tuning within Amazon Bedrock itself, like the native feature, just inference is like $20 an hour. So we're like really on a low budget thingy here. And I think we kind of figured out a good way to make this accessible for like poor people like AWS user groups, because it's basically it's basically, it's similar to a Netflix subscription.
And also, if you have any questions like regarding costs, different use cases, and whatever, please feel free to reach out to us, and so that we can talk after the session. Because we gained a lot of knowledge, and this is just like for our use case. We tried to add like the different scenarios, but it's just not possible. So it's really depending on your use case and on your data. So let's end with the key takeaways. So what we have learned throughout the way is, again, I think a lot of people already know that you really have to find a specific use case or a task. So it doesn't work that you have like this general knowledge, general use case, and just try to do everything like with one model or with like a multi-agent flow that's trying to solve like all of your problems. Then we saw that you really have to focus on high quality data and select the right model for your purpose, and also consider the high duration of the pipelines. So we're already done. Please, if you want to reach out to us, take a picture of this slide. And here is the user group toolkit where you can find our taxonomy. And then please give us feedback. And thank you so much. Looking forward to talk to you all.
Oh, thank you, Linda. Thank you for